Okay, this lesson is going to provide you some examples of continuous compounding interest. Here's the formula for continuous compounding interest. Notice it's a little different than just compounding monthly, yearly, annually. Okay, this is continuously compounding, and it uses E, okay, which you couldn't find on your calculator. So this is our formula we'll use. Again, A of T is the amount in the account after a certain amount of time, T. P is the original amount that you placed into the account. E is, again, just a number, which you can find on your calculator. R is the rate, which, again, we write as a decimal, change the percent to a decimal. And T is the amount of time. All right, so let's give this a go. Suppose $12,000 is invested at an interest rate of 6.5% per year compounded continuously. What is the balance after 20 years? So our amount after time T is what they're asking for. Our amount after 20 years is what they're asking for more specifically. The original amount of the account, or P, is 12,000 times E to the rate is 6.5%. Again, we want to change that to a decimal. You would divide by 100 or move the decimal 2 places to the left, times T, which in this case was 20 years. Notice we're not really solving for any variables. We just have to evaluate this side of the equation. However, you want to be very careful. Order of operations is crucial. So first we need to find out what that exponent is. So we take 0.065 times 20, and we get 1.3. So we have 12,000 times E to the 1.3. The next thing in order of operations is exponents. So we're going to do E to the 1.3 power. And you should get about 3.669. Again, the more numbers you give when you're rounding, the closer you'll be to the exact answer. I'm just going to go 3.669 and cut it off there. Our last step is multiplication. So we take our 12,000 times that 3.669. Again, if you can leave the original number in your calculator, you'll get closer. If you go with this rounded value, you get 44,028. If you go with the unrounded value, you get 44,031.56. If you can leave the exact value in your calculator, that's going to get you a closer answer. Again, I'll be fairly lenient. If you're within a couple of dollars, I know you've probably done it right, and just your rounding has pulled your answer off a bit. All right. And again, anytime you look at these interest problems, you want to look carefully at what you're given and what you're asked to find. John bought a rare coin valued at $250. The coin increases in value at a constant rate of 2.4% per year, so there's our R. How much will the coin be worth 10 years from now? Our current value, our principal, is $250. Our time is T. We are finding A of T. So we're actually finding A of 10 because it's after 10 years. So the amount in the account after 10 years would be 250 times E to the 0.024 times 10. Again, notice our percent, we changed to a decimal before putting it into the problem. Again, you want to find that exponent first. So we find we have 250 e to the 0.24 when we do the multiplication there. Your next job is to do the exponential part. So we're going to do e to the 0.24. And again, this can easily be left in my calculator. For writing purposes, I'm going to round it, but I've left the number in my calculator so that I can just multiply it by 250. Okay, so that's the rough amount. Again, the more you round, the further you'll get from the exact answer. But you should get something around $317. I get $317.81. Okay? All right, hometown Georgia has a population that's growing at a constant rate of 9%. At this rate, how long will it take for the town's population to double? Now, this is not an interest problem, but it is a growth problem, and it does say that it's growing at a constant rate. So we can use basically the same formula. The population after time t is going to be p e to the rt here. So Georgia has a population that's growing at a constant rate of 9%. At this rate, how long will it take for the town's population to double? So notice they didn't tell us how many people are there now. They didn't tell us, how many people they're going to end up with. They just told us that they want it to double. So the amount we end up with should be twice 2 times p, twice the original population, even though we don't know what it is. We're just going to call it p. E to the rate is 9%, so we get 0.09 when we write that as a decimal. And how long will it take? We don't know t. Notice we have 2 different variables there, but again, what we're going to do here is divide both sides by p, and notice p will cancel. Again, I use 2p because they want to know how long for the original population to double, so it would be twice the original population. Now I have 2 is equal to e to the 0.09t. To get that t down out of the exponent, we're going to do the log of both sides. We are going to do the natural log for sure here because we're dealing with e. That just makes things a lot simpler for us. Because we know that when we take the natural log of e, that equals 1. So we just have 0.09t. Equals the natural log of 2. So to solve for t, all I have to do is divide both sides by 0.09. And the amount of time it takes for our population to double, again, be very careful. Do the natural log of 2 and press equals, and then divide by 0.09. And you get about 7.7 years. If you want to round that up to 8, that's perfectly okay. Okay, so about 8 years is how long it will take for the population to double. We could figure that out without even knowing what our population is now. So again, important to read through the problem, see what you're given, and then assess where to go from there. In this case, we were only given the interest rate and the fact that it was constant. All right, we can use this in science problems also. It's called uninhibited growth, and notice we have the formula down here. This is straight out of your books. Okay, the amount of organisms, notice this is very similar, n of t instead of a of t. Okay, the amount here is given by n with the little 0. That means the initial amount of the population. E to the k times t. If it's growth, k is going to be a positive rate. That's your rate of growth. And t is the amount of time. Now, it may not always be in years. It may be in minutes, maybe in seconds. It just depends on how they set the problem up for you. So let's take a look at this. A certain population has a growth rate of 12% per hour. If the population begins with 6 cells, how many cells will there be in 18 hours? So what do we have so far? We know that originally there were 6 cells. That's our n naught. Okay. E to the, do we know the rate? We do. It's 12% or 0.12. Do we know the amount of time? We do. The amount of time is 18 hours. So we're going to say that our t is hours. Okay. And what will the population be after those 18 hours? So we do not know our n of t or n of 18 in this case. So we just have to evaluate that, but you need to remember to use order of operations. So again, we need to know what our exponent is up there first. So let's take our 0.12 times 18, and we get 2.16. The next step would be e e to the 2.16. And lastly, we'll multiply by 6. Again, the less rounding you do, the better. Okay, so for writing purposes, I'm going to write down, I get about 8.6711. Okay, but again, I left that whole number in my calculator. I multiply by 6, and I get about 52 if I round. So after 18 hours, this population of 6 cells will have grown to 52 cells. All right, this one's a little bit different, and as our last question, it is going to require a bit more work from us. A population of bacteria doubles every 12 minutes. If the population begins with 4 cells, how long will it take for it to grow into 680 cells? Okay, so notice we are given the original amount, okay, but if we tried this, we want to know how long before it's 680 cells. So we'd have 680 equals 4 e to the, but notice we don't know the rate and we don't know the time. So we're going to have to do a little work first before we can do this. Okay? We need to find out what our rate is. We do know that it doubles every 12 minutes. Okay? So whatever our original amount was, we're going to have twice that amount. Well, they gave it to us. If they didn't, I'm going to do it as if they didn't give us how many we started with, just so you can see that. Okay. I don't know the rate. That's what I'm trying to find. I do know the time. Okay, this is step 1. We have to find our rate first. And notice if they wouldn't have even had to give me the original population. Okay. They could just say that it doubles every 12 minutes, and I do 2 times the original amount is equal to the original amount. Okay, I have e to the r times 12. Again, we have to get that variable down out of the exponent, and to do that, you take the log of both sides. In this case, you would want to be sure and use the natural log, since the natural log has base e, so that natural log e is 1. And so we just have r times 12 here is equal to the natural log of 2. All I have left to do is divide both sides by 12. Now notice this is not the answer to my problem. They didn't ask for the rate, but I had to find the rate in order to find what they wanted, which was how much time it takes to grow to 680 cells. So again, very carefully do the natural log of 2 and then divide by 12. And you should get a rate of about 0.0577. All right, now that we have our rate, let's go ahead and find an answer to this problem over here that we started. How long will it take to reach 680 cells? We now know that our rate is about 0.0577. Okay, if we wanted to write that as a percent, it would be 5.77%. But since we want it as a decimal anyways, we're not going to move that decimal over. Okay, and from here, we're going to solve for t. So we have to isolate that thing that's being raised to a power. So we're going to divide both sides by 4 to start with. And we get 170 is equal to e to the 0.0577t. Again, our t, or our variable, is stuck up there in the exponent. So what we want to do is do the natural log of both sides so we can bring it down. In this case, we're fortunate natural log of e is 1. So we just have 0.0577t. And over here, the natural log of 170, all we have left to do is divide by 0.0577. to get T all by itself. Okay, so you can see it's very important to read the question and know what you have and what you don't have and steps that you can take to find those answers. And you should get about 89. Our time was in minutes up here, so it would take about 89 minutes for the population of 4 cells to grow to 680 cells. So again, that provides you with an example of uninhibited growth.